In this video, we'll be going over the pseudocode of LRU cache. So we will first start with the duplicate linked list and also the duplicate node. Inside the duplicate node, there will be 4 fields. So the first one is the key associated of this node, and also the value associated of this node, and also the previous node, and also the next node. Now we can implement the duplicate list. So the fields we need is the sentinel head of the duplicate list, and then also the sentinel tail of the duplicate linked list. The head and tail are just sentinel nodes that will allow us to have an easier time with our implementation of our methods. So inside the constructor, we're going to set head.next. So we're going to initialize head and tail, and I'm going to set head.next to tail, and I'm going to set tail.previous to head. Now one of the method is add first, so we add a node to the front of the list. We need the add first method because when we access a key, we want to move it to the front of the list because the front of the list contains the nodes where they are recently used. The elements in the front of the list are recently used. So I want to set head.next to node. Before that, we want to set node.prev to head, and I want to set node.next to head.next. Then I want to set head.next.previous to node, and I'm going to set head.next to node. Now we want to remove a node from a duplicate linked list. This is because when we access a key, we want to remove the node, and then the node may be at the center of the list. So we will first want to disconnect the references. So I want to set node.prev.next to node.next, and I want to set node.next.prev to node.prev. Then I want to set node.next to node, and then I want to set node.prev to node. Then we can return the node that we have removed. Now we want to remove the node at the end of the list. So when we perform a remove last, we need a remove last because when our cache exceeds the capacity, we want to remove the node that's at the end of the list. So we want to perform a remove method on tail.prev. Because tail.prev contains the node that's at the end of the list, and they want to return the node that we have removed. Now let's implement the cache. So what fields do we need? We'll first need a map. The hash map to quickly retrieve, or we can say to map the key to a duplicate node. And also our nodes is our duplicate linked list, and also the capacity. This will be the input capacity later. Now I want to initialize map and nodes, and then we want to initialize capacity. Now we want to get a value associated with a key. So we'll first check if the key exists or not. So if map does not contain key, this means there's no value, so we can just return -1. Now we want to retrieve the node associated with key. Now every single time we access a node, we want to move it to the front of the list because it's recently used. So we want to remove node from nodes from our list, and then want to add node to the start of the list. Then we want to return the value, so return node.value. Now we want to put key and value, which means updates or add. So we'll first check if the key exists in a map or not. So if map does not contain key, this means we need to create a new key value pair inside our map and also inside our list. So we're going to create a node with the key value pair. Then we want to put key and node into map. Then we want to add node to the start of the list. Then we will also want to check if the map exceeded the capacity or not. So if map.size is greater than capacity, we want to remove the last node inside nodes. And we have a method before to remove the last node in our list. Then we want to remove last node.key from map. So we want to remove it from our list and also remove it from our map. Else, this means the map does contain the key. So map contains the key. This means we need to update the value. Now we want to retrieve the node associated with key. And we want to remove node from nodes because we are currently accessing the key. We want to move it to the front of the list. Then we want to update the value. So we want to set node.value to the input value. Now let's go over the time and space complexity. So in our cache, the space complexity is O of n plus O of n. So we get O of n, where n is the capacity. The first one is our map, and the second one is our nodes list. Now let's go over the time complexity for the get key. So when we try to get, so we want to retrieve the node associated with key. And since we're getting it from our map, it's going to be O of 1. Removing the nodes is also going to be O of 1 because we are using a doubly linked list. The moment we have access to a node, we can just remove it from our list. So it's going to be O of 1. And then adding it to the start of our list is also O of 1 because we're using a list. We are not shifting elements or nodes down. So it's also O of 1. So the whole method is O of 1. Now let's go over the time complexity of put, key, and value. So in this case, we are checking if the map does not contain a key, which is O of 1. We're going to create a node. We're going to put the key and value and key and node into the map, which is also O of 1. Adding a node to the start of the node is O of 1. Then we check if the capacity is greater, if the size is greater than capacity. Removing the last node from our list is O of 1, and then removing a key from a map is also O of 1. Else we want to update the value. So we retrieve the node associated with key, which is inside map is O of 1. We remove the node from nodes, which is O of 1 because we're using a duplicate linked list. And then we add the node to the front O of 1, and then we update the value. So it's also O of 1. In the next video, I'll be going over the code of the LRU cache. Let me know if any questions in the comment section below.